Wanted to make a quick point finishing out this lecture on potential energy due to gravity. Only the direction of displacement that is in line with the force actually matters. So what if we maybe started at some origin? We could call this 0, 0. It doesn't matter. It could be, we could have called this 3, 2 if we wanted to, and really all that matters is delta y or delta x, remember, the displacement. But what I want to show you is, what if we took some path up to here to some delta x and some delta y from our initial point. So here's our initial point 1 and here's our final point 2. Then that means we would actually be looking at the work being done being equal to that applied force that we did before up here, dotted into the delta r vector. So remember that the applied force lifting the book was in the up direction, and that was providing just enough force to have an acceleration equal to 0 to lift the book with a constant velocity. We're going to find out, we don't care what the acceleration is, we just care what its final position is or what its speed is. But we have to change this up a little bit because we now have a x and y coordinate. So let's say delta r is equal to some delta x in the I direction and some delta y in the j direction. Then if we calculate the work, that would be mg in the j direction, in the positive direction, and we'd be dotting that into delta xi and delta yj. Now when we do the dot product, only the like components count. So, only the like components count, the j components, right? So we don't have to j dotted into I is equal to 0, but j dotted into j is equal to 1. So we can say the work, even though we took some path that went off to the right, since the weight was the only force that we were working against, that the work ends up being just an mg delta y. So we don't have to consider the x coordinate or the displacement in the x direction at all.